everybody, and welcome to another episode of our Fusion Zero to Hero series. And today we're going to be looking more specifically at the additive manufacturing process, 3D printing aspects and capabilities that are available to us within Fusion 360 or Fusion, Autodesk Fusion. So today we're going to be looking at how we can take our designs and be able to push these out either to a slicer software, bit of software, or do the printing and the slicing in-house, and do a bit of simulation and that, and establishing toolpiles and the like. So as we've seen in the manufacturing, the toolpiles episode, we want to take our design from where it currently is within the design workspace and push it through to the manufacturing workspace. So just for the sake of this particular production over here, we want to have this housing. We've created it as a bit of a base for the impeller that we're going to be placing inside of it, and it's just going to be for display purposes. So the fact that we're 3D printing this, the fact that we're making this out of plastic isn't too much of an issue, obviously. And for prototyping, this is great, but I guess for the most part, when creating a component like this, you wouldn't necessarily 3D print it, and we are obviously aware of it, but just want to show that the principles behind the workflow. So taking the design, we've gone through the design of this product in various different processes. I've just gone ahead and added a few touch-ups on the model itself. So added a fillet in here just to smooth out the design a little bit, as well as adding some embossed text along the side faces over here. Those are literally just text fields within a sketch. So if I double click inside here, you can add using the create panel text, add in the text you want in the sizing you want, and basically place it in as is. And then using the emboss tool, which we have available to us within the create panel as well. We have emboss, which will allow you to emboss or deboss the text. So I've got the Zero to Hero over there, and I've got the Fusion over here. So if I double click on here, we've got the ability to take that text, reposition it, place it in different locations. So if you are ever wondering how to do that, this is essentially the way we can do it. We can specify the depth, whether it's a deboss or an emboss. You can decide from there how you'd like it to go. So those are the only major modifications we've made. One other small modification we've made is just added a few extra holes in here. Because of the way we're designing this, we don't want to have to unscrew it and screw it every time. So we're going to add a few little magnets in there just to make sure that it's nice and neatly together. But that's again more for display purposes than for actual functionality purposes. So just a few little bits in there as we go through. So without any further ado, we'll head over to the manufacturer space once more. So switching from the design workspace to the manufacturer workspace. This is where we would then begin to start creating the setup and configuration of our printing setup. And then towards the end of this video, we'll then add in the time lapse of the model being printed off and the final finished product once we actually get to that point. So with this particular one, we want to print this in two separate builds, three technically if you're going to include the little spindle on the inside, but this particular model we're going to print off in two separate parts. So we have already split the component into two, but with a top half and a bottom half. But in this case, we want to also then set up the print for both the individual instances. So we've got a few variations in ways we can do that, but the main way you'll probably want to do that from within inside of Fusion, in whether it be the additive environment, the milling, turning, and so on, is to create separate manufacturing models, one for each individual setup. So rather than just selecting a single component, you can then basically remove the other ones from within the setup for each individual setup. And to do that, we can go into our setup panel. We have the create manufacturing model option, otherwise in the drop-down create manufacturing model. This is going to go and take the model that we already have here and create a manufacturing model of it within the browser, whereby we've got I've got two instances now. So I've got manufacturing model 1, which I'll leave as the original manufacturing model 2, which I'll then use for the bottom half, and then maybe create one more manufacturing model for number 3. I can come in and rename these. So I'm going to call this one encasing bottom, and this one encasing top. Cool. And then against each of these, we can then begin to make modifications. So for the encasing bottom, I'm going to activate it to make it my active model, the one that I use as default, but I can also right click on it and edit the manufacturing model. And during this process, I can come into the setup over here and either toggle the visibility of upper, or I can delete the upper. So that's not going to be taken into consideration during the print itself. If I finish edit on here, I've got encasing bottom. I can then activate encasing top, and I've still got the original one in there. So any modifications we make in the original model will be fine. They'll be pushed through to these. They'll be linked to those, but these don't push back to the original model. So I can go and edit manufacturing model, find the lower half, and then delete it. So I've now split them into two separate components, basically. Another way you could have gone about this is actually save them out as their own individual components. And if you are exporting out of Fusion, this is potentially the way you would do that. You'd go from within the design space. You have the ability, as long as these are their own individual components, you can actually right click on them and either up until this point we've created a component of it, but we can also save a copy as something. So it's going to copy this out of this current model and allow us to go. Otherwise, we could also export the model as well, the individual components from within the design. So back inside of this, I'll go into the encasing bottom and then create a setup. So from here, it's then the same process, and you could create the setup first and then the manufacturing models, or the manufacturing models, and then the setups. Doesn't really matter too much from that side. But inside of the setup, we'll go ahead and select the machine that we're going to be machining this on. So within this library, this brings up the Fusion library for machines, where we can got the ability to go and grab from any of the Fusion preset machine within the library itself. So if you've got a particular vendor in mind, you can go and grab from the vendors. You can filter this list, whether you're using additive, cutting, milling, inspection, and so on, and then go and grab yours there. The one that we're going to be using isn't within this list, so we could go in and create our own model in there, and our own machine rather in there, whereby we've got the ability using our machines or my machines. I can go and add a new machine to my library, in this case an additive, where I've got the ability to add information about it, including the platform dimensions, any limitations within the design itself, what the extruders are, and any settings regarding those, and any post-processing. So if you've got your post-processor in-house as well, you've got the ability to load that in or create your own one, and vice versa. So full customization available there. But we do have this custom one in here that I'm going to be making use of for the sake of this demonstration. So this is going to have a bed for us. As you can see in the background over here as a preview, we are using the additive setup type, so that's fine. And we do want to enable automatic arrangement. We can also, or in this case, I'm going to disable that and arrange it myself. And then from the model perspective, we can choose which manufacturing model we're using. So whether we're using 1, 2, encasing bottom or encasing top, or any other variation from there. We can also specifically or select rather the individual component that we are using at that particular point in time. So I'm going to go and select that one there, hit OK, and then this will go and bring this in. This is going to give us a verification that currently, because I didn't choose the automatic placement, the model isn't sat directly inside of inside of my machining bed, or my printing bed rather. So over in the position tab, I've got the ability to either move components, minimize build height to optimize the building height based on the geometry itself, I can use automatic orientation. I can use the arrange functionality if I want to place multiple components in, and also got the ability to place parts on platform. So if I have a look at this from the side over here and use my place parts on platform, select the parts that I want to place on the platform, and any clearance that I might require, and then go and hit OK, and it's going to go and place them directly on the platform over there. Now, hasn't positioned them correctly because I haven't used the automatic orientation or positioning at all, but I'll just go use the normal move tool, and I've got the ability to move it either in a plane or in an axis, just to get this positioned a little bit better from there. So if I go and grab my component, move it about into the position I want, so this fits nice and neatly in there. I've made a custom bed for it. But I can also go ahead and rotate it around 90 degrees to make sure that it is going to sit nice and neatly in there once more. So just going to bring this ever so slightly down here and reposition it from this side to make sure that it fits completely within the bed. And then I will also go and run that place parts on platform option, and it's going to place it nice and flat on the bed itself. From there, we got the ability, if we wanted to, make any other modifications, whether we have supports already in place and want to split them into mesh bodies that we can kind of move around independently of each other. If we've got quite a few of these components that we want to put in, we can go and fill the void with items, and then use our supports to then kind of structure them together if we wanted to. We can also add supports in, which I'll do with the other example. But essentially from here, we should just need to go in, right click against this and generate the toolpath. And based on the filament settings that we've got, this will then go and generate a toolpath for us nice and easily like that. If we do decide that we do want to make adjustments to the printing setup, we've got the ability to change the printing settings, which have been inherited by the machine. And we've got the ability to come in and choose different printing setups from within here. So if I make a modification to any one of these ones very quickly, let's go and grab this one quickly and edit it. We've got the ability to make modifications to a whole range of settings in here, including the presets, what the normal is, what the extrusion values are, shells, infills, bed adhesions, supports, how we adjust the volume supports, the bar supports, the setter supports, and a few others. So whether we're using a normal setup, a strong setup, and so on. So a lot of information we can make modifications to from within the menu as well. Now that has gone and generated that, we've got the ability to very quickly go in and do a nice simulation of the toolpath itself, just to identify that it has done everything that we expect it to. So I can jump straight into a simulation environment over here, whereby it'll quickly load all of those toolpaths, all of the layers, and enable me to quickly have a look through those. So we can see based on the colorization of each of those passes, as I'm sure you're familiar with most other 3D printing software. We've got our outer perimeter highlighted in red, we've got our inner perimeter in green, and then we have our infill in orange. If we have supports or bridges or rafts or primes or skirts and brims in there, they'll also all be color coded. You can see the infill I've got over there, and the print as it would go through from top to bottom. We've got the ability at the bottom of our menu over here, or the window over here, to click on the timeline, to click on various points in the timeline to identify where we are at any point in time. We've got the ability to play this through layer by layer, pass by pass if we wanted to, and start to see how this would then be created and printed throughout. We've very quickly got the ability as well to establish how many layers there are in this particular build. And we should have an indication as well at this particular point in time as to which layer we're currently on. We've also got the ability to see how long the expected time is according to machine, according to capabilities, and so on. So we've got a real quick visibility on all of these details from within here. Once we are happy with that, we can then essentially just post this straight out. So as long as we've got our post processor sat within Fusion, we've got the ability just to go and push the G code out directly from inside him. So most of the standard, forgive the scaling on here, most of the standard printers will have their own post libraries in here already. So if you are looking to place this from a lot of the standard libraries, you can see we've got a whole range of posts available to us for various printers. So there is a huge library available to us, but then if you do have a custom post for your own printer, you've got the ability to set that up from inside here as well. And then it's simply a case of hitting post, provided you've got the correct post. The machine doesn't matter as much as the post does, so as long as you've got the correct post, this is what will be pushed out correctly. And then for our second setup, I can go in and create another setup over here. Again, using the same machine, so using my custom machine over here, I've got the ability to this time around, rather than using the encasing top, printing off the encasing, encasing bottom, printing off the encasing top, using the same print setup as we did in the previous one. And then again, using an additive arrange in a 2D strategy, we could use 3Ds or in a bounding box or Monte Carlo format, where we can see that this is going to try and optimize the best placement for this based on the positioning that it was in, and move it in a 2D aspect. I do want to again go and rotate this around 90 degrees, at which point I can go and rerun that additive arrange option, which should go and give a good positioning for this now straight back to the bottom over there. So it just depends on the orientation that it was in when you start this operation, basically. But once you've got that set over there, it's then a case again of making sure you've got everything detailed in the way you want to, setting up the printer setup, printer settings. In this case, we probably want to go and add in some volumetric supports. So in this case, down along the bottom face of my part over here, because of the way this particular model is coned, we also want to then be able to make sure that as it reaches the top point, it has a little bit of support. And then one of the settings, one of the tests that we've run for this particular one, we're also going to, in the final finished product, make sure that there's a bit of a bridge between these two arms or these two elements over here. Otherwise, there's a long portion of it being unsupported from the rest of the model. And so that just leaves room for it to start sagging and to kind of move either too far in or too far out. So adding a little bit of material on a build, something like this, just to between these two will then help and support that a bit better as we go through. But I'm just going to go and add those surfaces in here. We've got the ability to choose the support overhang angle, so the angle at which the supports then make contact at. So if our surface reaches 40 degrees or so, that's when it will essentially make contact with the support and be supported from that point onwards. In the general tab, we've also got the ability to set a top distance to the part and a bottom distance to the part as well. This, depending on the complexity of the support itself, this might take a while to go and calculate, but a few of the other support types that we have available to us, we do also have bar supports. So if we are using any overhangs a little further up, and we don't want to make contact with the bottom of our part but come in from the sides instead, we can use our bar supports. And we've also got setter supports, which will encompass the full profile of our part and just help build up those supports essentially from there. So these are the three types that are currently available within Fusion. Again, as is the case in the last one, we've got the ability to generate the toolpaths, we've got the ability to simulate the toolpaths, and then post-process from there as well. So realistically, again, much the same as before, except this time around, we've got a little bit of extra support on the inside surfaces as well. So if I go ahead and simulate this toolpath, we can see if we go somewhere a bit further back along the route, just catch up with me for a few seconds. Sorry, just realized I didn't regenerate the toolpath since I generated the support. So let me do that one more time quickly. And as soon as that's generated, we can go and run the simulation. But yeah, other than that, the other options that we have for exporting this out in the actions panel, you can see we've got the ability to export the 3MF file for this. So if you wanted to do the configuration and all of that from within Fusion, and then push this out to your own slicer, you've got the ability to do that as well from here. Otherwise, as we saw earlier, we can export this file as well, which is the case that we're going to go through for this particular one. We're using the manufacturer's own slicer for that particular one. And in that case, we can simply just go and do a file export and export out into the file format that you require, whether it be, again, a 3MF file, whether it be a step file, or whether it be any of the other file formats that you require within the software that you use. And now that that one's gone in and completed, I'll go and simulate it very quickly. And we can see as we bring our part down, we've got a few structures in here for the support. And then we've got the wall itself that's being built up. So one area that does obviously, or the main area of concern along this is the fact that this entire stretch all the way back to somewhere along here doesn't have any support back to the central model at any point. So in the software that we're going to be using for slicing, we're just going to go and add a little bridge across here just to make sure that it is connected, which you'll probably pick up in the time lapse as well, and maybe add a few extra ones in there just to keep it nice and structurally sound during the printing process. We're fairly confident that once the cone comes over, or once the tube comes over and merges back up with itself, that should hold quite nicely and then fit quite nicely on the bottom half as well. But I suppose at the end of the day, for this particular example, this is still a prototype phase, and we're just going to be using it for display purposes. But hopefully this gives a good insight as to the full start to end process that is available to us from within Fusion. And yeah, if you have any questions regarding any of this, please feel free to get in contact with us, and we'll be more than happy to assist with that. Other than that, for now, thank you very much for your time today, and enjoy the time lapse. Bye for now.